In this lab, you may notice that every once in a while, there might be this value given before this value, or maybe this value before this value. They're going to be very close together. It was just done this way to help with the flow of the video so that students can understand what's going on and so that it makes a little bit more sense visually, but that didn't always match up perfectly in the order with this chart. Also, this is part A. The initial measurements for copper and aluminum will happen at the same time, but the experiment for aluminum is recorded before the experiment for copper. These boxes are filled out and the rest are calculations. We'll visit those after you have the information shown above.
So I need the mass of each of these metals, and I'm also going to weigh the mass of water in the calorimeter, because remember, hot metal, we're going to go in room temperature water. We're going to have the temperatures of both of them, and we're going to see when they equilibrate what the final temperature is. The heat is going from the hot metal to the water that's not hot. Let me make sure it's still tiered. You can always push it. All right. So I'm going to put 40 mils of water. Okay. And you're probably thinking right now, why don't we just use density of water and calculate it? Okay. Well, this is going to give us a better measurement of the amount of water. Now, this is where I'm going to be pouring the water. I want this tiered because I want the mass of the water that's going in. All right, so that is tiered right there. I'm going to put my 40 mils. Oh, give it a second. Since these don't fit in, so just note that it's a little bit less stable because I don't have the top section closed. So it keeps going back to 0, so we're going to call that good. I'll pour my water in. Got a drop left. I'm going to try stand really still. Now again, it says water in it. It's going to be tilty, so I'm going to put it in here. The only purpose of this is to keep it from falling. So I'm going to take the silverish colored one. Now notice, I want the mass of this, so I need to make sure that I tare. Notice it's in grams, so that's really nice. I'm going to open up my door, put them on there. I'm doing the same thing. I'm going to get 40 mils of water. Pour it in. Going to try staying really still. And so this is the water I'm going to be using with this silver colored piece. And again, I don't want it tipping. This is just to hold it. So now we're going to go on over. These two metal pieces are going to be placed in the boiling water, and then we'll get our reaction going. Don't leave your graduate cylinder. Them out. I don't want to transfer the water, just the hot aluminum piece, but I want to move fairly quickly. We're kind of waiting for a peak here, and I want to make sure that it makes sense. You put something hot and something room temperature, so the room temperature thing should be going up. I'm measuring. You can see this is not on the metal, this is in the water. So I'm measuring the water changing, but it's going to keep changing until it peaks and they both are at the same temperature. So okay. Now I'm gonna wait just a second. This needs to get re-equilibrated to the temperature of this water. Almost, maybe.
Mm-hmm.
Okay. Stir in the water. Go ahead and turn this off. And again, we're looking for a peak in the temperature. Go to one. Okay, I think that was the peak, 32.1. So at that point, what we're saying is the water and the metal have reached the exact same temperature at that 31, and now it's going to start losing heat to the atmosphere and the air and the room until it gets down to the temperature of the air.